Hello guys, I am Leferdi. I'm a Brazilian guy. I previously lived in Kansas in the United States and I loved it. Go Jayhawks. Today I'm gonna be teaching how to make a very good cell shader in Unreal Engine 5. This is our current scene here without our cell shader. And this is our scene with the final result. So basically we can see that shadows are clearly separated from lights. So go back here, it's more clear in those cliffs. Remove it, and go back to it, right? So for those who don't know what a shader is a computer program that runs in your GPU. Basically what that shader does is it gets an image from the input from one side and do some math with that image and outputs another image on the other side. That's what a shader does. And everything in the 3D world and maybe even in the 2D world is drawn by a shader basically. Whenever you want to place a texture into a 3D model, but you basically use a shader to do it. I mean, even if you don't, some other program or framework's doing for you. For those who don't know, a cell shader is a shader, a post-processing shader usually, but not always, that separates light into groups. So that instead of having a realistic look in your scene, you actually get something that looks more cartoony or something that was drawn by someone. So we can have a look here in this Breath of the Wild picture that our light here is separated in groups. You can see it here in the shield where there's this shadow and then this light group here. Same thing for the hair, you can see it's like this medium level light in the hair, but then here in the side you have a more intense light. Games like Breath of the Wild, Tears of the Kingdom and Wind Waker use this effect, also Genshin Impact. I think it's quite nice, it adds to your game this timeless feel to it. So even a game like Wind Waker, if you play it in the GameCube, it kind of holds itself high as in graphics quality, in my opinion, even in today's world. So I really like it. I think it's a nice effect. And if you're making a game and you're using lots of assets from different vendors, it's also a nice glue that you can use to make those assets look more or less the same, because everyone's going to be post-processed the same way. So I think it's a very good technique to use and it gives a very good look to a game. Back to our scene, this is it with normal Unreal Lighting. It's kind of bland. This is it with my final result cell shader. Note that it's kind of very intense, right, the lightning, but it's actually how I configured it to be, because I like this look. But you can configure parameters that's gonna make it look less intense or more, and that's up to you, the customer, basically. My idea here is to explain every part of the construction of this shader, so even a new person to Unreal can make it. So I'm gonna disable my finished product here because we're gonna start from scratch. So first things first, we need a post-process volume in our scene. We can create one by clicking this add to project button and searching for a post-process volume. A post-process volume is basically this cube or this box that whenever the camera is inside of it, the effects that you apply to this cube are gonna apply to your camera. But there's a problem here, right? We want our cell shader to affect the whole world, not just this cube. And we solve that with a nice feature that is a checkbox called Infinite Bounds. infinite extend or unbound. This basically makes our cube infinitely big. So we check it. Then we change the name of this post-process volume to CellShader tutorial volume if we want. And I'm gonna move it to our Lightning folder here. So you can do the same thing in the default Unreal third-person template or first-person template. It's gonna have a Lightning folder like this one. But you don't really need to put it in Lightning folder, that's just for organizing myself. So, now that I have this post-process volume that's affecting the whole world, I need to make a material, which is basically the way that you can make shaders in Unreal. We can add a material to it, so that whatever my material says that this post-process volume should do, it's gonna be applied to the camera when I am inside the post-process volume. So I can create here a material to put there anywhere, but I'm gonna put it in my CellShader folder here. You can put it whatever you like in your project. I'm gonna call it PP post-processing CellShader tutorial 2, because I already have on the past a tutorial one here. Now I'm gonna assign it here in this post-process materials of this volume, and I'm gonna open my material view here. In the material view, we have a preview on the left side that shows how our material affects the object and the ground and the background and the skybox. Initially, this material is set to surface. It's usually a material that you're gonna use in a mesh, in an object, but we are not doing that. We are doing some post-processing, and it changes this block here, which is our output node, and we only have one output here, which is a emissive color, which is basically the image that our camera is gonna receive at the end. To avoid bugs, we're gonna change a parameter here. It's called blendable location right here, which basically dictates when our post-processing is gonna happen. So there are several steps of post-processing in Unreal, and we want to do it in one of the first ones. I'm gonna put it here, scene color after DOF, and I really don't know what DOF means, but it's here that we have to actually do our things. So as I said, the shader receives an image as an input and outputs another image that we changed. But that's not all it receives here. So our shader, our material, is gonna receive several things as input. We can get those parameters, those values from Unreal using this node here, scene texture. This scene texture node has several types, and each type is gonna bring us another parameter. So we can get the scene color, scene depth, so basically how far away the pixels are from our camera, the diffuse color, which is the usual lighting color, the specular color, which is the very shiny, intense light hitting our object, the subsurface color, which is the lightning, the light color below surfaces like the skin of someone, so basically the light of their veins. We have metallic color, which is basically the light reflecting off metallic surfaces. And then we have some things that are not color, so the word normal, for example, which might feel an angle of between the pixel and the word, opacity, roughness, etc. So important to our shader is going to be the diffuse color, specular color, subsurface color, metallic, and material, ambient occlusion, and ambient occlusion. Ambient occlusion is basically the shadows that the objects make themselves. And we're gonna see the other things. So I'm gonna output here our diffuse color, which is the usual lighting value for things. And most cell shaders you find in the market just use this value here to get the light, to do the cell shading, but it's actually the source of many bugs. For example, if you look here our mannequin from Unreal, it's all black because we're not getting the metallic light out of it. This ripple in the water here, it's an unlit material, so it also doesn't have a diffuse color or like usual lighting value out of it. Also, we have this light here which is purple and it's not showing at all, and we are not seeing the occlusion or material occlusion in these rocks. So those are all the problems we have to solve. Also, the sky is black, which is probably because it's probably also unlit like those ripples. We're gonna solve all of those problems. To get the cell shaded effect, we need to separate our light values into groups. So a group of intense light or less intense light or not intense at all light, and then some shadow group and darker shadow group and so on. So as I said, this is basically our usual light level, but we have to calculate a light intensity so we can separate our groups. There is this post-process input 0 here, which is basically the image that we would output if we didn't do anything. So if I change here to be our output, you're gonna see that everything's normal as it was before. So if with this image we can calculate a light intensity value. Basically, first we desaturate it, making it black and white. I'll show it here. Ta-da! And then we do the same thing to the diffuse color, which is our lighting value. And we divide one by the other. And this gives us a nice lighting value. Wow! It's very intense where it should be very intense, and it's darker where it should be darker. There is an issue with this though, which is basically, and there is no light at all. It's not totally dark, but we're gonna solve it. Actually, I said something not completely right. Point being here is actually our diffuse color. If we save it here, this guy here, it's not gonna be completely dark when it should be. If I remove all light, nothing changes. There is an issue, but back to our shader. So this division here gives us our lighting level measure. So we could call it this block here, this whole block actually, our lighting level calculation. I'm gonna comment here, light level calculation. Alright, okay. But as I said, there is an issue with this. Our metallic bits are black. They're not receiving a light level at all. And since they are not receiving a light level at all, we can, since it's not receiving light at all, we can just improve this by also using the metallic, by adding actually the metallic light. So I'm gonna change this node here to a function that I'm gonna call it CellShader tutorial get light level. Get light actually. And in it, I'm gonna add the metallic color. So basically, I'm gonna have here metallic color and the use color added together. I have to save both, and that gives us the lighting level to our mannequin character back, and also those metallic bits. So that's a problem solved. Also, we have those unlit materials such as the sky and the ripples that basically you can see that even though the light levels for metallic and diffuse, which is our usual light level, are bigger than 0, our sky and our ripples are still black, so they're still 0. So we can use a if function comparing our light level, actually our light level is this guy here, our actual light measurement, let's say, comparing it with our normal usual image. And basically, if our usual image has an intensity bigger than the light level, we could use it as the light level for those images that are not being affected right now. So if our light level is A and post-processing input is B, whenever B is bigger than A, so here we want our output to be the image as it was. But this is gonna make us go into some trouble if we're not careful. Otherwise, we got the color light here. See, this gets us into some trouble because many times the final image is going to be more intense than the light level calculation. So what we can do is multiply this by a very small number, such as 0.1, and that's the actual measurement we are going to measure against. Alright, and now it's working, I guess. This is our light. So this is our light as usual, and this is our light with the light level in. So it solves the sky issue and the ripples issue. Alright, so I'm gonna call this here the unlit section. Unlit Passthrough. Alright, now we have two values here, our light level and our light measurement. Usually the light levels are numbers between 0 and 1, and by dividing one number by the other we can actually get numbers bigger than 1, and that's how we're gonna separate our light groups. So if I say that our light is, for example, bigger than an arbitrary number here, it's gonna be 8, I can say that we are in the maximum light group, and I'm gonna use a constant here in the beginning, and I'm gonna call it the topmost light intensity, and the usual value is gonna be 5. So it might sound weird. So basically, if our light calculation is bigger than 8, we're gonna set our light level to 5. If it's equal to 8, we can also set it to 5, and if it's smaller than 8, we can multiply it by a value such as the light level times our second most intense group constant. So basically convert this constant here to a parameter that we're gonna name top light intensity and C2, right? And I'm gonna put this value here at 4, for example. So if it's bigger than 8, we're gonna set it 5. If it's smaller than 8, we're gonna multiply by 4. Multiply our usual light level by 4. And that makes our first light group. So we could plug it in here, and it makes things very intense already. Now, that's because we only have the top light intensity parameter right now. But if we make another light group, such as the, I don't know, third more intense group, I'm gonna call it third light intensity, I don't know, and it's gonna be the same thing, our light level multiplied by a number, and if it's also our light measurement here, and now if it's bigger than a parameter we're gonna make called the third light limit. I'm gonna place this at 3. Then we're gonna use the light group above us to be our light source. Otherwise, it's gonna be this group, which is gonna have light level of 2, for example. So now we are taking into account both light group 1 and 2 and the max, and it's already a bit better. Okay, I'm gonna do this a few more times. This is, I'm gonna call it neutral light limit and neutral light intensity, and limit's gonna be at maybe 2, and the intensity is gonna be 1.5, and I'm taking these numbers out of my head, okay? So not anything that actually matters in a sense. But same thing, if the light level is above our limit, it's gonna be the light level of the other group. Place it here in our Unlit Passthrough. Voila, we have another group of light. Now we can change this limit. For example, it could be 1.5 here and 1.2 here. Maybe get a bigger space of this lightning group. Okay, and I'm gonna do the same thing, but as we go below 1, I suppose here is 1. Now we're entering shadow territory, so I'm gonna go to the shadow intensity, shadow limit, and shadow intensity, say 0.8, and use our measurements here again. Same thing, if it's above, we got the other group, place it here in our outputs. Okay, it's funny because our shadow group is still quite lighty. Let's make another one. And my point here is that eventually gonna run into trouble. Suppose 0.7 and 0.3, get the light again, right over here. The measurement goes here. Right? Oh no, what did I do? Okay, this is darker shadow limit. Okay. Other intensity, something wrong. Okay, another limit. Okay, there it is. So this is the darker shadow over there. Alright, starting to look somewhat like our final product. And the light limit is gonna be something like this. And we're gonna call it black shadow limit. Shadow speed. And the thing is become very big. It's also very simple. Oh damn. What did I do? Okay. Here is not 0.1, it's 0.5. I see what's going on. 0.1. Since it had the same name, it can. I think it was something like that. But yeah, it changed a bit. But this is what we got. Let's say 0.4. We got a little bit more shadow there. Alright, but now we have a problem. So our purple light here is not purple in most of its parts. And if we remove the light, we're gonna have that issue that I showed in the beginning. This thing is not coming completely dark ever. And that happens because we are using the light level as a shadow parameter, and that's wrong. So what we're gonna change is that whenever we are talking about shadows, we're gonna actually use our usual image as our input source. So multiply our input image by those intensities. We should do it to this one. It's gonna change things a little bit. Yeah, way darker the intensity of the usual post process here. But now if we move the lights, it goes completely black, which is what we wanted. Now we're gonna have to mess a little bit with the parameters here to get a better result. But that already gives us a better look. But this metallic stuff here is just pure black, it's not really good, right? Now that we need to change a few parameters, I'm gonna make a material instance of our tutorial shader. So basically we right click our tutorial shader and then create a material instance of it. And here it is. And I'm gonna keep the name. When we open it, you can see that there is a bunch of parameters, the ones we have been making so far, that dictate how our limits are gonna be and which intensity they're gonna have. So if we go to our shadows, we can start with the shadow intensity and bump it up so it's not as, first we have to use the material instance instead of the raw shader. Okay, now that we change it here, I can change the parameter here and actually have things change according to the parameters. So our first shadow intensity group shouldn't be too dark. I'm gonna put it more or less here. And our darker shadow intensity shouldn't be as dark either. Here. And our black shadow intensity, I don't think it's anywhere in the cracks. Don't need to be too dark either, but yeah, I'm gonna leave it that value over there. So yeah, not as intense as before. Maybe do darker this. And then we can also move our limits around so it looks a little better. Okay. And our barrel here is already looking better for our dude. Alright, okay. Now let's go back to our shader. So this big block here is our light groups. Nice. Alright. Now we have this light problem here. We want the light to be completely colored and not just a little bit. And this little bit here is because of our unlit code. It's not that good either. So what we can do is desaturate this output so that we only get light here and not color. You can have a look how it's gonna do this. Oh, we have an issue. Okay, so this is gonna be a sacrifice that we have to make. So a little bit of our grass, far away grass, are not gonna be CellShader. But it's alright. So basically, now that we have our light groups and shadow groups, we need to make our purple light work as intended. And we're gonna use the saturation node here to just take the light value out of our light groups. So basically, we're gonna have to add light to color later. And we do that by adding our input here. And this is our post-processing input, which is our normal, usual image. And normalize it, which basically means putting it back into the beginning of our vectors, and that's gonna give us color, just color, pure color. With that, we can multiply our color by our light that we got off our light groups. But we should also multiply our color by a parameter. We make this constant, and on the parameter we're gonna call it color intensity, which we're gonna put at default 1.5. We can finally multiply our color with our light level. Put here into our group. This gives us our cell shading with colored lighting. We solved our unlit materials already, our light color. We have metallic objects working. We just need material occlusion now. Specular lights and just together in a group called color addition. Alright, now before adding color, we are gonna add our ambient occlusion shadows, and it's quite simply actually. We just get our input for ambient occlusion, our input for material occlusion, material ambient occlusion. We multiply both, then we can multiply again by a constant. We're gonna transfer into a parameter called ambient occlusion level at 1 normally, and then we're gonna multiply our light by that before multiplying here. This is gonna give us ambient occlusion, not that hard. This is our ambient occlusion group. A comment here for ambient occlusion. Okay, now our CellShader already have most of its features. This is our cell-shaded meta-human right here. Quite nice actually. We go back to our getLight function and we have some stuff to do here. We need to multiply our metallic light by the specular light, which is the intense reflective light that you usually get into metals. Multiply it here. Probably change here something. So now there's this more intense light over here. Okay. Now with diffuse color, we're gonna add the subsurface color. We're gonna multiply it by a factor so we can control how much subsurface light we want. Subsurface light factor, gonna put it at 0.2 so it's not too much. We're gonna add it with our diffuse color instead of multiplying, and that's what we get for diffuse color. This guy over here has subsurface color. You can see that he got some shading after adding here. Alright, so our get light function is basically complete. I think it's important to add a parameter here for our metal. It's gonna be our metal light level. Metal light level. I'll keep it at 0.2 so it gets a bit darker, gives a nicer look. No, that's it. Alright, that's most of it. This is our get light function. We have the metallic down here, the usual light up here. Subsurface light we multiplied by a small number because it's subsurface. We have our light groups here, shadow groups, ambient occlusion, color adding, unlit pass-through. We can also have custom depth pass-through. Basically is when you check that a object has a custom depth, you don't want the post-processing to affect it. So basically what we need here is get the scene depth and get the custom depth, mask it using component mask. We only use the first value of that vector, and we make an if the custom depth is Specular, we use the usual image, otherwise we use our save it. Okay, it's the other way around, so it's bigger, we use the other image. If it's not, we use our. Okay, so if we come here to this rock and say I want it to be custom depth, its parameters and their custom depth, it stops being cell shaded. That's our last part of the cell shader. Alright, so this is the custom depth pass-through. Alright, that's basically it. Our cell shader is complete. All that is left is to configure the material instance so it comes closer to your liking. For example, if I want our topmost light to be more intense, we can control it here, or top light intensity, or the third light intensity, and we can control how big you want each of the light groups, and that basically changes how your cell shader is gonna look like. But that's it. That's how you make it. Everything else is up to you. There is a last step here that we can do, which is basically to rip off a Japanese guy cell shader. There is another part to cell shaders that's usually drawn in the outlines of our characters. It's like those brushes around their hands and feet and everything. And I actually got mine from GitHub cell shader that I found. Basically, I have it here. So it's this huge block that calculates where we're gonna put outlines. And then there's this part here that is where we actually mix the outline with our light calculation. So basically what you have to do is more or less the same I'm gonna do here. Just copy it from the Japanese guy project, all this outlines part. So there's edge line, crease line, depth based outline, normal based outline. You get all those tasty, nice outlines. And then we're you're gonna have this lerp here, which takes a float tree. So basically the Japanese guy goes up to this point here. Japanese guy, GitHub, blueprint. You take this, and basically what this does is that he calculates where you're supposed to put the outlines. So if I put it in here, you can see everything that's white is a outline, and everything that's black is not. So basically we do a linear interpolation using those values to say that where is white, you're gonna paint black with this node here, and where it's not white, we're gonna paint it with our light calculation. So we can do this before adding color to it here. So I'm gonna take this. This is a vector with 4 parameters, RGBA, and we need it to be only 3 values. Since it's black and white, I'm gonna use the same value here for the 3 of them. The output of that, I'm gonna send to our color edition. Voila, we now have outlines. Oh, actually, since this outputs a full float 3, we need to make a full 4. It's the same idea. Is that A is 1. Place it here. Shabang. Now we have outlines. It's the same CellShader light values, but now we have lines around our stuff. You can see it in the boy here. Alright, that's it. So it's the whole tutorial on how to make a CellShader in Unreal with mostly no defects. So basically, first part, we calculate the light. We use the light value over 1 to separate which group we're gonna use. So it's always the light level, it's the parameter in the if groups. At some point, we reach shadows, and in shadows we actually use our image darkness as input for calculating light level, as opposed to just the light that we get from light channels. Then we multiply by the ambient occlusion to get the object shadows. Then if we want, we can add the outline. I'm gonna link the GitHub of the Japanese project here so you can pick it up too. Then we add color, the unlit pass-through, and the custom map pass-through, and that gives us the whole CellShader. And that's it, guys. Thanks for watching. If you like the content, please subscribe. I'm gonna be making more, and see you in the next video.